So this is, I also came to know before a few days, but it's a hot topic, and it's it started coming in news from 2019, as we all know. JDK first introduced it in JDK 19 as preview feature, then it was also in JDK 20 as preview, and finally they have released it last year with JDK 21. And now you can try out this feature without, enabling the preview feature on in your Maven or anything. So I'll give a little background of me as well. So I am Medha Chakraborty. I work for BlackRock, and my experience has been all along developing applications like Java applications, full stack applications. So with my experience, when I heard about Project Loom, it actually attracted me to learn more about it, because it's kind of, something which we can use in day-to-day life while developing applications. I don't know how many of you are working on applications like, Java server, web applications. But the topic which I'm going to talk about, and I will be focusing on mainly how we can get benefit of Project Loom working on applications, web applications, or web server applications mainly. Okay. I think we can go ahead and start. Okay, I'm starting a bit early, but I think it's almost time. So, in the evolving landscape of software development, we all know that Java continues to be a stalwart choice for building reliable, scalable, and performant applications. The languages and its ecosystem have been evolved, incorporating modern paradigms and tools that cater specifically to the needs of high-scale applications. In JDK 21, Java released virtual threads, which is known as Project Loom. Project Loom introduces lightweight and efficient virtual threads, massively increasing resource efficiency while preserving the same simple thread abstraction for developers. So now, what we will focus on today's talk. I will start with thread per request model, because to understand where exactly Project Loom will come into picture and how we can get benefited, we have to understand what is thread per request model. Then we will also talk about platform threads, and then we will see how currently in present day, how we are trying to improve the scalability with asynchronous style programming. Then we will finally talk about virtual threads, its motivation and what it is, its goal, and what are its non-goals. And then we will slowly dive into more details of virtual threads, and we will see the benchmark of virtual threads and platform threads, and I will end up with some demo. Okay. Okay, here we go. So this is a sample web application. So how we build I will take an example of a web application which you see here. This is a Spring Boot application with Java. Okay. So what is happening here is, with any kind of application, from browser we send request, and the application receives the request to perform some kind of task, and to perform that task, it has to connect to, for example, to some database Also maybe have to interact with some input-output stream, write some data in some file, or send some messages through some brokers like Kafka, or maybe communicate with some other microservices. So in today's world, typically microservices work like this. So you receive request, and then you perform some task, and then you send back the response to the user. So now you have developed, according to your business need, you have developed an application, and you have run it locally, tested, and it's working fine, tested with Postman or something, it's working fine. Then you deployed the code into dev and TST, pre-prod went very well. So you are happy about the application, and then you finally released it in your production environment. So first, when users started accessing, it's fine, but the news about your application went, and the news spread, and everyone's wanted to access this application because you have because they have learned, heard so many good things about what you have developed. So the user base has increased. Now the volume of requests are increasing day by day. And now what happens is you start seeing your application crashes. So when you are requesting your applications, you often see that, few of the users are getting back response as 500, deadline exceeded, exception, etc., because your application is not able to respond the request back to you. So now we will see why the app starts crashing and what we can do to address this issue. So now we have to understand what is thread per request model. So here in this diagram, you can again see that we have a browser, the requests are coming in. Now think about your application, the Spring Boot application which you have developed. It works on top of thread. So how it works is, when you send one request to your server per request creates one thread, and that thread actually do all the work. So for example, you have written a code where you want to get some data from the database. So you call the database, then you get some result, and then you do some computation, and then again you call some REST API call to get some more data based on the result you got back in the previous call, and then you want to send some events, etc., so and so forth. So the user who has sent the request is waiting on the response to come back because his request is being processed, right? So one request is fine, one user is fine. Now day by day, the request and the user base is increasing. But the thing is, your application has a pool of threads which are limited. So for example, your application can support, and by default Tomcat, which is internally Spring Boot's internal server, that supports 200 threads. So for example, now the number of user has increased. So what is happening, till 200 threads, your application works fine, right? Because think about it, when you are processing some request, all threads are getting busy because they want to serve the request those already have came into your server. It's something like if you have went to into a restaurant, and it's a buffet, Sunday buffet or something, and you go and see that a line of people waiting for the seats, right? Because there are no seats available, and also there are no servers to serve you. So basically, then you have to wait outside until and unless the tables are available for you to sit, right? So this is kind of a scenario over here, what's happening. So how we can solve this? So this is happening because, as you can see, the maximum number of threads which your application could support has been exceeded. So to understand this, again, we have to go a bit deeper to understand what is thread, right? So thread is a thread of execution of program, and Java is all made up of thread. We all know that. And there can be two flavors of how you can use threads. Thread represent a separate path of execution of a group of statements. So basically, that is called parallelism. Like I am walking now and I'm also talking. So I'm doing two jobs in parallel. So one, you can think about one thread which is walking, another thread which is talking, and this is called parallelism in case of thread. And the next thing is thread also provide, and Java mainly, facilitates to allow multiple activities to coexist in a simple process called concurrency. So what is concurrency now? Concurrency is you are doing some work. Here I am walking and I'm talking, but if I want to drink this water, I have to pause, I have to drink the water, and then I can start talking. So this is called concurrency. I am doing two jobs, but to drink the water, I had to stop, I had to drink the water, and then again I could start talking. So this is concurrency. So in Java, a thread, and here in this diagram you can see in Java we have the thread, the concept of thread in Java is wrapped around the kernel thread. So in whichever operating system you are working, that operating system operates on processes that are also threads. So Java actually is built and wrapped around on those kernel threads and mapped one to one. So till now, these threads, what we are actually working on, are known as platform threads. And these threads are mapped one-on-one with your operating system threads, with your application or Java threads. So now come to see like how we were addressing these issues for so many days, because applications are growing, we are making our application scalable. So we were doing it by 2-3 options. First is hardware scalability. And when we talk about hardware scalability, we have vertical scaling, which is, you increase the memory and CPU of your server. And the second part is horizontal scaling. So it's not only one server, but you increase the number of servers, right? So that one server was serving 200 threads, now you have added 4 more servers, so you can serve 200 into 4, 800 requests. So you can increase that. Now the second option, what is available till date is asynchronous programming. So what is asynchronous programming? Asynchronous programming is doing the same job, but allowing you to, to allow your blocking operations, make them non-blocking. So when you call a database or when you call an API, those calls are called blocking operations because your threads are blocked and you have to wait for that data to come back. So when you are blocking, you can make utilize of your current thread by using this kind of asynchronous programming. So, but asynchronous programming has its pros and cons as well. So, what are its pros and what are its cons, we will see. So, when you add asynchronous programming, you get improved performance and scalability, you get better resource utilization, and also you get some non-blocking nature of application, so that your application is more responsive. So you don't have to wait for so long, and then also compressibility. So what happens is in these scenarios, your application now no longer wait for your database call. So you have written your application code in such a way with async programming that when you are calling a database, when the thread which has already sent the request to the database and was waiting for the response to come back, that thread is no longer waiting for the response to come back. Instead, it is, utilizing something. Okay, I will just. So what it does is, it doesn't wait for the response to come back, but it actually starts serving some other request or it start to, do some other work. And this scheduling is done by Java. So for this, I will give you one example, like the same example of a restaurant. You have went to a restaurant and a server came to you and, he has asked for, given you the menu and ask you to select the menu. But he won't stand until when you are, selecting the menu, because he has to serve other people. So if he stands in your table until and unless you have given the order, it's wastage of time, right? So what he does is he goes to some other table and responds to some other people. So exactly this is what is happening in case of just asynchronous programming. So we are able to utilize our resources in a better way, right? So, but this also comes with some cons. What are them? So if you have written like the asynchronous programming, like, features, compatible features, and also event looping, and also async features which Spring Boot gives, if you have written those kind of code, you have seen that, the debugging of the code becomes very difficult. Whatever you have sent to the code and however many lines you print out, if you get some exception, it's very hard to debug and understand exactly where it is failing. And if you are trying to do some computation on top of that, it's your time is like gone. So also to understand how this complex asynchronous programming behaving, it needs a steep learning curve. It's not that, it needs some time, right? And also they have some testing difficulties as well. You are mocking some of your services, but you have missed something. You won't even see, won't even understand. Your test fails, but it gives some random error. While you're doing the unit test, you can't even understand what's going on. Then you have to make the code changes and see where it is going. So basically debugging, it's a nightmare. And also it separates the thread from the task. So in a nutshell, asynchronous programming is obviously, it provides significant benefits in terms of performance and scalability. It also introduces complexity and potential challenges in code management and testing. It is important to balance the use of asynchronous programming with the application requirements and the team's expertise. So if you have to develop one, API within few days because your client has requested for, and it has to be scalable and it has to serve 1,000 users, then you will definitely start using asynchronous programming. But the developers you are using, they also have to be learned and they have to understand the code and has to produce that API in few days. So it's difficult, but we were somehow managing till now. Then the next thing is, before coming to virtual threads, the current platform threads, what are the problems with the current platform threads? So the basic unit of concurrency is thread map one-on-one with the kernel thread, which I have mentioned, and it's expensive to create. And it also uses memory, so it becomes expensive, and the expensive to switch in the sense the scheduling which we are doing, right? So that also becomes scheduling which JDK does, that also becomes hard for the JDK. And limited in number, so often we get memory out of memory stack exception. So these are the current problem which we have with platform threads, but till late we are working on it with the hardware scalability and asynchronous programming. But now it's a good news for all of application developers, all of us, that JDK has finally introduced and released JDK 21, which has these virtual threads. So Project Loom, they defined, like Project Loom aims to drastically reduce the effort of writing, maintaining, and observing high throughput concurrent applications that make the best use of available hardware. So what is virtual threads? Here in this diagram, you can see that you have OS threads And each OS thread is connected to a platform thread, which you have seen in the earlier diagram as well. But from here you can see from each platform thread, there are multiple virtual threads got created. So these are super lightweight threads which Java JDK 21 has introduced and gifted us so that we can use and make our life more easier. Now, what is the motivation and goal? So the motivation of introducing virtual thread is to enable app server to scale, of course, optimal hardware utilization so that we can make best use of the hardware which we are working on. Third, enable existing thread code adaptation. So it's not like, I will come to what are the non-goals, but these are the three things they have mainly kept in their mind while creating virtual threads. Now, what is not the goal of the virtual threads? It's not goal to remove the existing thread implementation. So we are not removing the platform thread implementation, but on top of that, we are building virtual threads whenever it is necessary. Secondly, the migration from platform threads to virtual threads, it won't be silent. So you won't be doing it silently because you have to have the knowledge of where you will be using a platform thread versus where you should be using a virtual thread. So they have the migration is also not silent. And also it's not the goal to change the basic concurrency model that Java already has for concurrency. So we are not changing the concurrency model and also not the API. So all the Java Stream API, whatever parallel stream, all those things will be there. But in the back end, whenever needed, Java gives the flexibility to create platform threads as well as virtual threads. So we will go a bit deeper to see how virtual thread work. So there are 3 points. They share OS threads. So virtual threads many virtual threads can share the same OS thread, not capturing it for the entire lifetime. So basically, the OS thread which generates a per platform thread, that platform thread actually helps us create multiple virtual threads. But these virtual threads are not, capturing the actual OS threads. So it's not blocking the OS thread, right? So one OS thread A, if they have generated virtual thread V5, and when virtual thread is in action, the OS thread 1 can, do some other work. Second thing, transparent scheduling. Virtual threads run on OS threads when active but are transparently scheduled by JDK scheduler. So the scheduling is also done very transparently. And the third is same functionality. Virtual threads have the same functionality as platform threads, like thread locals and stack traces. So you don't have to, for the async programming we have seen, right? There is a huge steep learning curve, right? But here we don't have to deal with that. I will, when I show the demo, it will be more easier for you to understand. So what are the features of virtual threads? Unlike heavyweight platform threads, virtual threads are cheap to create and can be created in large numbers. So it's not since it's not tied to the operating system, it's not, it can create multiple and huge number of virtual threads, not like the platform threads. Traditionally, threads were pooled to limit cost, but it's not a concern with lightweight virtual threads. So previously, when we used to do our programming, and now also what we do is we create a pool of threads so that, we can take the thread from that pool and we can work on that. And when the work is done, the thread again goes back to the pool, waiting for another to start another job. So here, in case of virtual threads, we don't have to create a pool and limit the thread. Okay. So, and the third thing is, obviously, when we are talking about concurrency and scalability, the throughput is very high. What does throughput means? when you are waiting for some job to be done, or when you are working for something, the response is very fast, as many workers are working for the same thing together. Previously, it was, you can think from this way, like one job, when you are doing one job, you have assign 2 resources to do that job. Now you can assign 5 resources to complete that job, dividing the work. So obviously the work will get completed in a very less time. So that's how the scalability and the responsiveness increase, and obviously the throughput. Yeah, I have already mentioned the number, you don't have to pool them. And also, it's important to remember that virtual threads can be created on demand. So it is not that you have to, you can mention that, previously we used to say thread pool of 50 threads, 100 threads, or something like that. But here there is no limit. You can create unlimited number of virtual threads. But now we will come to the cons. First, we will see 2 diagrams which we have, which I have 2 graph. This is an experiment which I have done, which shows the benchmark of platform thread versus virtual thread, which I will show you in a bit. So we can see the number of threads, like how the throughput, like what is the throughput, what is the benchmark, and you will be able to relate once I show the demo. So now I will talk about one more thing. So we have been talking about all good about virtual thread right now. So there is one, so now we have to balance it, right? Like we have to understand when to use virtual thread versus when we should not. So we have done some experiment on virtual thread on some computation work. Like virtual thread is very good on IO, like inbound, outbound, when we are waiting for request and response. But when we are working on a particular memory and doing some computation, so is it that great? So that is still, like, we get some benefit definitely, but the computation is still something you have to analyze when you when you decide to use virtual thread. So basically, when you start writing your code, you have to think where to use virtual thread versus where not to use virtual threads. Like in case of inbound, outbound request response systems, you should be using virtual threads, versus when you are computing, like if you are working on AI where you are doing large number of data and only concentrating on the dividing a task in your heap or stack and then doing some computation, in those cases it's better to use the platform thread. Okay, so now what I'll do is I will slowly start showing some demo which will make you understand how virtual thread is working, right? So I have JDK21 with me, and I will first show you some demo. First, let me show how easy it is to create. Yeah. Okay. Okay, maybe I don't know which we can. Now can you see? Okay. Thank you. Okay. So to start with a very basic example. So how we used to create platform threads. So this is a very basic way we used to create platform threads, right? So here you see I am creating platform thread, which is just a thread class which extends threads. And in the run, what I'm doing is I'm just printing a statement. I'm just printing this is a platform thread, and I'm printing the current name and saying it's running. So here, how I do it, these are the two lines, platform thread, thread new, platform thread, and I just do thread.start. So this is a basic way how we used to create our threads. Now how we are creating virtual threads. So I know this is also I have take help of the new Java JDK 21, but this is a very simple way you can start, so that there is no complexity. Instead of virtual thread, you can start with virtual thread. There are many ways you can start a virtual thread and create virtual thread. This is one of the example. I will show you other examples too. So here what I am doing is starting a virtual thread. So this program which I am going to show you now shows what it does is, I will first go from here. So this is a Spring Boot application. I know I am not using this Spring Boot application as web application right now, but for our benefit, what I have done is, if you go here, if you edit configurations, what I have done is, I have done kind of a stress testing or performance testing, you can say, where I am sending 10, 100, 1000, 10,000, 1 million, 10 million, 100,000 and 1 million number, and based on this number I will be generating threads and I will be doing some job, and then we will track the performance, how platform threads perform versus how virtual thread performs, so that it's very obvious, we can see what benefit we can get out of this virtual thread. So what my program does is, I will start up the server, right? So I will give some introduction, and wherein this kind of whatever I have written, wherein we can take advantage of. So I have one application and I work in BlackRock where we have to update our data very often, because we deal with trading data, we deal with regular all the stocks, right? So it goes up, down, and the prices changes. So every day morning we have to get the latest price update, and then the trading system can start trading or post orders, whatever. So it's a everyday job, to get the latest updated data and fill our cache with those latest data. But we cannot do a downtime for that, right? It has to be a very little downtime, or this whole caching process, caching mechanism should go in the back, but without affecting any request or without affecting the throughput, right? So from my coding experience and what I'm doing right now today in my code versus if we can implement virtual threads, how it will improve, I can show you. So basically, what I'm doing over here is, as I have shown, I have getting the number of threads 10, 100 in the VM args, and then I'm creating platform thread, and also I'm creating virtual thread, and then I'm generating the graph. So let's not generate the graph now. Let's just see how much time the platform threads take to start up the server. And imagine that while starting up the server, in case of huge number of data, you might have to call, in a scenario, multiple applications to add data to your cache. So that server startup also takes some time. So here we will see with the platform thread how much time it takes versus when we use virtual thread, how it works. Okay. So first I'm running it with platform threads. So I have shown you that I'm just printing a statement. So think of you are calling here a database, getting some data, then with that data calling some other API, getting some other data, and updating your cache. right? You are doing multiple things, and at the end of the day, your server starts up and is all ready to be served users for their requests. So here what I'm doing, first I tried with 10. I can break down and I can show slowly as well. Maybe I should have broken down the list with 10, 100 and 1 million, but then it will cross time. So what I'm doing is I'm just trying to start the server with multiple threads and see how fast the server can start up with platform threads. Okay. So that's the reason why, in case of, like, if there is some restart, we have some defect, we got some defect in our application, and we have to push the defect changes, and we have to restart servers. Then we get very worried that if we have to stop the server and start the server, it will be a long downtime for us, and how we can manage this. So I feel like these issues can be eventually addressed with virtual threads. Okay, it's taking, yeah, it will take some time. So it's 1 minute past already. It's doing nothing, just printing. So can you see the time? Your server now started and it took 126,007 seconds, right? Which is 2 minutes. Now we will see how long it takes for the virtual thread. So what I'm doing here is I have created this virtual thread and I have added a countdown latch. So like this countdown latch just counting number of operations you are doing. Once all the operations are done, then you are ready to start up your server. So it's a basic example which we do for any kind of Java startups. Okay, now I will stop the previous one and will start the same thing, same work, printing the thread with virtual thread. Okay, that's it. So it's done in 17 seconds. So can you imagine the same number of threads we were working with platform thread versus virtual thread, the amount of time increment we got. So that's the benchmark we got, like how first we can start our servers. So this is, again I'm saying, this you have to keep in mind that virtual thread you have to use very efficiently, and whenever you are doing any IO operations, it's commandable, and it's said that you should use virtual threads so that you are getting benefit out of the waiting time on the threads, right? So here you can see the platform thread took 2 seconds versus like 2 minutes it was, because it was 126 seconds. Here it is 17 seconds. So it's a huge benefit if we use virtual thread. But I will show you, this is the benefit of the virtual threads. Now I will show you something else, which is the inbound. This was IO bound. I will show you an example of inbound, which means how virtual threads performs in comparison to platform threads when you are doing some computation on the same hardware. You are not going outside, you have all your data and you are just computing in the same memory, same hardware. No waiting time on threads. So how that will work out? So So here what I'm doing is, here also I'm doing the same thing. I have created executors. So if you see here, this is also important. So when we create our executors with our platform threads, this is how we create executor.new cache thread pool, and we pass, and this is for creating with platform threads. And how it is changed when we are using virtual threads, this is one more way I am showing that how you can create virtual threads. And this is executor's new virtual thread per task executor. This is, but it's very easy to remember, and there is not much understanding of the code like learning curve or anything. You just, the API has been written same, only a new method which with virtual threads. So here we will see, and what I am doing is, here I am just printing, I am passing 1 to 64 integers, and what I am doing is, here this is the actual work I am doing. I am just changing the index number and I am printing a code for it, where a two-digit code. So if I am entering 1, then my output will be 0, 1. So this is some computation I am doing on the data which I am inputting. So for this I am not going out or doing any other job. So for this we will compare and see how our threads perform. So first we are running the platform thread, and then we will run virtual thread. So it will take some time because it's doing some job. It started. So the job for executing platform thread has been completed. The task for virtual thread has started. And you will see the comparison report here. So here what you see, at the top we see the virtual thread and below the platform thread. So both of them has done the same work, but platform thread has a consistency and the job has been completed within 24 milliseconds or something. But here platform in case of virtual thread, you see it started fast, but ultimately it took around the same time that average platform thread has taken. So what I wanted to demonstrate here is, this is where we have to think while using virtual threads, right? When your work is inbound and not communicating with other resources, in that time you have to think whether to use virtual threads or you should go with platform threads. So this is the difference between IO bound versus CPU bound. Okay. And lastly, I will show one more thing. Just to show, I was saying, right, we have OS, this is the number of cores, and then this is the platform thread, virtual thread. But we might want to see what is this core, what is this platform thread, how it will look like. So for that, what I can do is, if I go to my task manager, and if I see my, one second, performance. One second. Why it's not showing? This is my CPU. I want to see my core. Do you know from where we see the core? So when we come here, this is some place only we can see our core. The number of core my laptop is currently using. this gets printed somewhere here only. This is resource monitor. Okay, but we can figure it out with an example in my code. But it skipped my mind from which tab I think from settings. Yeah, so here I think, yeah. So here it is. So yeah, thank you. So here, if we click the CPU, you can see what is the core of my laptop. It has 10 cores and logical processors is 12. So basically it acts as I have 12 core processors in my machine. So what I'll do is, I will run one application, like one code basically, to see, so to print, what is how many core I have in my machine. And we can see, like, whatever we are checking here, we see the same thing from my code as well. And then we will see, to run this program, how many pool has been generated and how many platform threads we are using versus how many virtual threads we are using. Okay, so to see this, what we are doing is, we are starting virtual threads. So this is one more thing. You can just define the thread, and then you can start whenever you want to start the thread, right? Here you can see, this is a list I have created with all the threads, virtual threads, but then I'm printing it at the end. So basically in this program, my main aim is to generate virtual threads. But in the background, what I want to see is how many processors are there, and then I want to see, to generate this virtual thread, how many actual platform thread was used to generate these 50 virtual threads, and what is the core pool which was automatically created behind the scene. So yeah, it was quick. So you can see, this is the number of core which I have shown you here. So this number matches. And then there was only one pool created, and the name of the pool is fork join pool. It's a common, so that is like when you start up a Java program, it's the main thread which is running, and this is the main fork join pool which has been created. 9 platform threads were used. So you had option for creating 12, but 9 was used. And finally, there were 50 virtual threads got created. So just wanted to demonstrate that when we are creating virtual threads, because here I have just started virtual threads, but behind the scenes, what is actually happening, it's as I shown in the picture, right? So when you are creating virtual threads, it is actually it is actually created on top of platform threads. So platform threads facilitates to create virtual threads. So yeah, this is all I had to show, and thank you everyone for attending this, and thank you Ajag and Devnexus for giving me this opportunity to present this talk. Thank you. Sorry? Yes. So the demo is there in GitHub. It's private, and yeah, of course, you're welcome for any questions you have. Sorry?
Yeah, so one thing I saw is that you're using system on prem, right? And most of our applications we're using log.
No, this is, yeah, this is not at all my actual application. So if you want to see if how I code in my company, it's totally different than this demo code which I have shown. So it's interesting.
Well, hold on, let me ask the question.
Yeah, yeah.
So let's say we're using log4j.
Mm-hmm.
Do we know, or do we have the ability to switch, if we can, to virtual for those IO operations when it's
Sorry, I'm not
writing the log. So when it's writing the logs, right?
sure. Yes.
Yeah, it's an IO operation,
Yeah.
So theoretically, by what you said, that you probably should be using a virtual thread there. Do we have the ability to change that for Log4j, or will we not see the benefit, even though we're using virtual, but
Yeah.
we're not
So
using
for
a logging framework that's
yeah,
not using it? Will we not really see the benefit because of that?
see, so for logger, when you are using your log in your application, the logging, how the logger is acting is abstract from you, right? So the logger API has to use the virtual thread in order to take the advantage of that, right?
Well, does it mean, but how do we know that it is?
How Log4j is implementing, I'm not sure, like how Log4j has already implemented the virtual thread, but if you want to implement that, that is your question, like.
No, no. So like right now, like if I took Log4j as right now, it's probably not using virtual threads.
Right, right.
So how do we? Is there? So
Is
how
there
are we
any?
knowing that it's taking advantage of it? Is the question, because if we're gonna intentionally use uh, these virtual threads for those operations, you want the logging system to do the same.
Right,
Case,
right,
it depends on sometimes different frameworks have different enabling devices. Like with Spring,
right.
you could by default Spring's going to use the traditional thread model, but you can set a configuration to switch it to a virtual thread virtual thread model. So in this case, Megan, I don't think I'm done, but I think we have to do we have to look at the manual and see how to do
Yeah,
it.
the Log4j. Like what I think is when you start with Log4j, right? What we do is we set up everything in our Log4j XML, right? So which all class we should be printing, so on and so forth. So maybe when they introduce Log4j, we have to see the Log4j manual, and then maybe we have to change this um, Log4j XML or something here. We might, set up somewhere here. That's my assumption, because virtual thread is just in. So all the supporting application to start using virtual thread, they also have to enable it. So I know for sure that Spring is using, and Spring is using very efficiently. They have, as mentioned by Glenn, right? Uh, just a configuration change and you can start using virtual thread. So to use Log4j, since it's an application outside of your application, a third-party application, you have to see the manual and see the configuration, how you can enable virtual thread. Yeah, like, here we have this level and stuff, right? So there should be some, but this is a good question. I will look into it to see if I can find out if they have already done something on this.
I think the loggers, when they log the statements to, if it's a file-based logger, when we log something, some statement, right? The log itself executes in a separate thread than the mainstream thread, correct?
Mm-hmm.
Now this question, lies upon who is provisioning and giving the thread to the logger, correct? So if I think it's the main application. See, all the threads are born out of the main thread, correct?
Right. And so
So the main thread is the parent to all the threads, whether it's a virtual thread or a real thread. So I think it shouldn't be inside the logging framework. I think it should be who is uh, invoking the logger, right?
So that can be, yeah, that is also one thing, like how we are maintaining our application. That is one thing. And along with that, yeah, that is also correct in a way. Yeah. I haven't tried with Logger yet because I didn't have the provision to try with Logger, but yeah, this is a good point. We can.
One more thing. So I personally believe, like that's my belief actually. Not only for IO, because the traditional threads were 1:1 mapped with the OS threads, right? And the problem there was OS threads were limited, correct? So whenever the traditional thread gets blocked, it's as good as saying the OS thread is also blocked, correct?
Right.
Because they are like completely fused with each other. Now, I believe that not only for iOS, there are other cases where also the traditional threads get blocked. For example, inter-thread communication. When a thread is waiting on an object, so that time thread gets blocked because it goes into sleeping state, right? That means you are also letting the OS thread to sleep. I think think not only for I/O, but if you have too much internet communication,
Yeah, that is,
applications will use virtual thread actually.
yeah. I mean, yeah, but yeah, like when you, that in those cases, you know your application better. So I would just suggest, like, if you're using virtual threads, blindly you can use virtual threads in case of I/O communication. Whereas when you are taking care of your own code and you have the ownership, right? So think wisely and the decision making comes into picture, right? Like whether you should be using it or not, like whether to go with virtual thread or with platform thread.
Yeah, for the Log4j, there's a Log4j 3622 support for virtual threads. There is a long discussion on the advantages and disadvantages of using virtual threads as it pertains to their logging framework. I was going to read it and try to do a TLDR, but the TL was very, very TL. So look up Log4j 2-3622 and see if that helps out.
Yeah, thank you, Glenn. Yeah, okay.
So what's the difference between computable future and virtual thread?
So no, there is computable future is the same thing. It's the API which Java is providing, right? So
I mean, how does virtual thread make this into the computable future now?
so the work will be done behind the scene. So when you are initiating your threads, right? For example, if you are using Spring, so you will be using some framework, and also you are using the Java API for that. So you have to let know the Java API that use virtual thread instead of uh, platform thread. That is only your job, because Java API knows when you tell Java to work with virtual thread, the scheduling and the generation of virtual thread, whether it has to wait, whether it will be working only with platform thread, that is abstracted. You don't have to, so you will see the performance.
I have to write to build this asynchronous concurrent call. Let's say that I have to call an API 1,000 times. So we are splitting up those calls and making concurrent calls, like 10 calls in a batch, something like that, right? So that is not going to change. More that I have to write.
Yeah, the blocking thing is going to change, because when you are calling, the calling with a thread, right? And the thread behind the scene is waiting for the job to be completed, right? So you won't see that the thread is waiting. Rather, Java knows when to release that thread and when again to assign the scheduler to get back to the work and complete the thread. I mean, complete the job. So
I see some improvement in the performance now, so with virtual thread
yes,
platform thread.
yes.
The code that I need to write to build these concurrent calls and also there is no change in that. In Java 21 as well, is that correct?
Yeah, like you have to call virtual threads wherever you need, rather than, like, your code will be simple and you don't have to, for your async code, like for your asynchronous code, right? You mention async.
Yeah, that's what I was.
Yeah. So in those cases, Spring takes care of that. And in those cases, like whether if you are depending any framework, you just need.
Not using Spring. I mean, I'm not using Spring.
Okay. So if you're not using Spring in any in Java application also, you can, like when you are creating your thread pool, like when you are creating executed dot new thread pool, you create executed dot create new virtual thread pool. I have shown you in that one code blog as well. So if you say create pool of virtual threads, it will create virtual thread pool instead of creating platform. Yeah. Okay. Thank you. Thank you, everyone.